A deeper look into the moon Titan. Welcome to another video. If you enjoy this type of content, then subscribe and hit the bell icon so you never miss out on any of our latest and greatest uploads. The surface of Saturn's moon Titan looks a bit like Earth, and a new study finally explains why. Saturn's largest moon, Titan, features some very Earth-like landscapes. Lakes and rivers, labyrinthian canyons, and soft sand dunes. However, these geological formations on Titan are made of entirely different materials. Instead of water, it's liquid methane that flows through rivers, and instead of sand, it's hydrocarbons that blow into dunes. For years, scientists have been stumped by how these landscapes came to be given their un-Earth-like composition. But now, they've determined a very plausible theory. Because Titan's sediments are theorized to be made from solid organic compounds, they should be far more fragile than the silicate-based sediments found on Earth. Thus, nitrogen, wind, and liquid methane should wear Titan's sediments down to fine dust, which wouldn't be able to support such varied structures. University has come up with a potential solution. A combination of sintering, wind, and seasonal change may be able to do the trick on Titan. The researchers studied a type of sediments called the Ooids, which can be found on Earth and which have a similar composition to Titan. Ooids can be found in tropical waters where they form very fine grains. These grains simultaneously accrete material via chemical precipitation and erode in the sea. As a result, they maintain a consistent size. The researchers think that something similar might be happening on Titan. We hypothesized that sintering, which involves neighboring grains fusing together into one piece, could counterbalance abrasion when winds transport the grains, L'Apôtre said in a statement. The team then analyzed atmospheric data from Titan as recorded during the Cassini mission to determine how those sediments could have formed such vastly different geological features observed around the planet. The researchers discovered that winds were more common around the moon's equator, which created optimal conditions for the development of dunes. Elsewhere, however, the team suspects that lower winds allowed coarser grains to form and, in turn, more solid sedimentary rock to form. From there, wind could erode the harder rock down into finer sediments, just as what happens on Earth. Furthermore, because Titan is known to be the only celestial body in our solar system besides Earth to have a seasonal liquid transport cycle, L'Apôtre's team then hypothesized that the movement of liquid methane likely contributes to erosion and sediment development too. We're showing that on Titan, just like on Earth and what used to be the case on Mars, we have an active sedimentary cycle that can explain the latitudinal distribution of landscapes through episodic abrasion and sintering driven by Titan's seasons. L'Apôtre said, "It's pretty fascinating to think about how there's this alternative world so far out there where things are so different, yet so similar." And with that, we've reached the end of this video. If you've enjoyed this video and found it helpful, don't forget to leave a like and subscribe for content just like it.